Welcome to this new Construct 3 demonstration where I will show how to create a realistic rope effect like we're seeing here. So what I'm doing is I'm clicking with the left mouse button right now, and you can see the ball is stretching a rope effect here. It's moving along with the mouse cursor. When I let the mouse cursor go like that, it creates kind of a hammock. And clicking the right mouse button will spawn a number of balls which fall into that hammock. So how does it work? So first and foremost, this is the ball which is already on the layout when the game starts. It's just a ball with a physics behavior which isn't movable, is not immovable, and it has a collision mark of a circle, obviously, because it's a ball. So some light settings here, low density but no friction, elasticity or damping. Pretty basic. And then there's a second layout where two other assets are available. You can see here the green ball, which is also having a collision mark circle, and pretty much the same settings. And there's a link, which is also not immovable but has a higher density. Basically, and we'll be using a combination of those links to actually create the rope. Now you might see that the link here has inherited the physics behavior from a family, and you can see this family here, chain links. You might ask yourself, okay, the link is the only object in a family, why would you use a family in that case? Well, we'll see that in a minute when we look at the code. So looking at the code, on start of layout, we will set the world gravity to 5. So there's a light gravity going on here, and we set the physics of the ball to immovable. And next we will create a chain, and to do that we will call a function called create chain with a number of links of 20. It's just a parameter, you can increase or decrease that. What happens here, there's a repeating loop, repeat number of links times, that's it. So what it does, it will loop through all of this logic number of links times, so in our case here 20 times. First thing it does, it's creating a link on the 0 layer at the ball x and y coordinates. When that's the ball, of course, that already exists. We set the angle and we move it at that angle, loop index times link width -4. So it's creating links one next to the other because angle 0 is going to the right, and we spawn links from left to right, loop index times width -4. The -4 is to create, of course, some overlap. And then we set the links physics enabled. And then the loop goes on, and you can see here that there is a special case where the loop does something for the first loop index, and it also does something for the last loop index, and everything in between follows this logic. What happens actually in the first loop index, we need to link the link we just created to the ball which is already on the layout. To do that, we create a revolute joint and using the physics behavior of the ball. So you can see that here we're creating a revolute behavior of the ball, a revolute joint rather of the ball, and we do that, we link the link we just created at image point 0. So that way we're actually linking the link to the ball, and the link can move freely around like it's being pinned to the ball, but that can move around in angles. So that's it. If that's not the case, we will pick the previous chain link. The previous chain link is actually something we set here at the end of the loop. We save the unique ID of the link in a variable called previous link. This is the definition of the variable. And here we pick it. And why don't we use link? That's because otherwise we cannot do this action. We can't say link to another link, because construct doesn't know which link to link to which link. This link which is being picked here or the one which is created here. So we actually pick the chain link with that UID we just saved in the repeat loop before that, and then we link to the physics to the chain links using the physics behavior and the revolute joint once again. For the very last link, you can see it, loop index is number of loops minus 1, because the loop index starts at 0, of course. So in our case, there will be loop index from 0 to 19 because of there are 20 links being made. The last one, we will create a new object, add the image point x and y coordinates of the link, the image point 1 of the link, and then we will once again create a revolute joint to the ball. That's what we mentioned before. We save the previous link in every loop, and then we calm the chain down. You set the physics velocity to 0 because otherwise it would be very squiggly. So finally, what it does here with the left mouse button down, while we're dragging, we're applying some physics force towards the x and y coordinates of the ball, so it comes along with the mouse cursor. And when we release the ball, we pick it and we make the physics of that ball immovable. And then when clicking the right mouse button, there are objects being created of type green ball, and you just fall to the ground and they are picked up by the hammock. That's it. So basically that's it, how you create a realistic rope effect. I hope you liked it. As always, please like and subscribe, and see you next time.